Thank you, everybody, for turning up to the pretentious, anspruchsvoll und überheblich talk when there's a wonderfully good chef talk across the way. So hopefully it'll be worthwhile. There's a lot of talk about the cloud at this conference, and indeed probably at every technical conference today, yesterday, and probably tomorrow as well. And we often talk about this metaphor as if we already understood what we meant by it. But as we'll see when we go through it, we don't all understand what we mean by it, and we don't all mean the same thing when we use it. So it's always worthwhile to step back a minute and to think philosophically about what exactly it is we're trying to achieve when we're using this metaphor, and what are the pitfalls for those of us who believe in free and open technologies. So just to reiterate that, there's a warning. This talk introduces absolutely no new cool hardware. It's not about a wonderful new GitHub project. We're not going to be building a cheap SAN out of Raspberry Pis today. It asks a lot of very vague questions. It provides very few concrete answers, and it meanders all over the place philosophically. So if you suddenly realize that you've got a lot of chef to be learning, I won't be insulted if you decide to leave. On the other hand, if you want to consider some of the bases for all the very interesting technologies that will be discussed over these next few days, then maybe it's worthwhile staying. We're not here to diss agile technologies like Puppet and Chef or projects like OpenStack, but to misquote Socrates, an unexamined cloud is not worth hosting on, so let's see what we mean when we talk about these particular words. Now, it was made very clear that there is to be no self-promotion by any speaker. However, none of you have heard of me, so it's right that at least I introduce myself. I have a degree in English and philosophy, so of course I went immediately into computing. That's what one does. And with my ex-computer science teacher, I actually wrote the first book about the internet in schools in the UK in 1993 and 94. Went on about gophers and wastes and Veronica and Archie and all those sorts of things, so it's very relevant today. In 97, I co-founded the Positive Internet Company, which is not dissimilar from NETWAYS in Germany in as much as we're a managed services company that runs completely on open source and free software, and we provide solutions for clients from the biggest banks in the world right down to, or indeed up to, Richard Stallman's website. And he's constantly asking us to do very interesting things like make sure that Apache doesn't log any IP addresses because he doesn't want to breach anybody's privacy and things like that. So we're always kept on our ethical toes by him. But on the other hand, we have insurance companies who demand PCI level 1 compliance, all running on top of the LAMP stack. So we have a very wide range of clients, and the one bit of self-promotion I'll give is we did win a Guinness World Record for the Ricky Gervais podcast, which when it was launched, had the biggest amount of podcast traffic ever in a day. So that was a pleasant surprise. Now, we all know that the cloud is ubiquitous as a term. I realized this when not only were my colleagues talking about it, not only were people I knew in tech talking about it, but my uncle in America, who knows nothing about tech and is a complete technophobe, started asking me about what this cloud was. And he genuinely thought that it had something to do with hosting things in the sky. I don't know whether he thought that there were servers on a Zeppelin or something, but there seems to be a generally confused misconception about it. And you might say that's the fault of those who haven't studied the technology properly, but actually, as we'll discuss, there is something inherent in the use of this metaphor itself which makes it confusing. So let's talk about the cloud. Is it a brand new way of thinking about computing that so many people say, or is it an old idea that's been rebranded? And whatever the case, it is the zeitgeist. My uncle talked to me about, he's never talked to me about anything else technological. Every newspaper writes about the cloud and how you'll be saving all your data to the cloud and how sites are hosted on the cloud and how the cloud is somehow going to solve all our environmental problems by consolidating power and so forth. How did it become the zeitgeist? Well, let's go back to the chap who invented the term. And we're in Nuremberg, so let's ask Hegel. He spent plenty of time here. And as you know, he invented a way of discussing progress, or he rather consolidated a way of discussing progress, which was based on dialectic. And in dialectic, there's a thesis which collapses, and then there's the antithesis, which takes the broken bits of the thesis and tries to put it back together again. Often it's the opposite. And then finally, there's the synthesis, which tries to synthesize that which works between the thesis and the antithesis, and then we start again. So we might say that the thesis that preceded the cloud was, most computing will be controlled by a clearly defined center and accessed from a number of peripheries. And we all know this model. The 1960s PDP, centralized, time-sharing model with the green screen VTs clustering it, very tight central control, but with users able to access those network services as though they had individual access to a particular service when in fact it was just being time-shared. The antithesis, as we know, happened from the mid-70s onwards, firstly with the invention of home computing, and then moving on to the personal computer, which reached its apotheosis probably with Windows 95. I think that was the last moment of the completely isolated, self-contained personal computer, where most computing will be controlled by self-contained local agents, and we remember what living in a world where PCs were all dominant was like, and networking was just an afterthought, if thought of at all. If you remember how difficult it was even to get Windows 95 and Windows 3.11 to connect properly to the internet. If anybody remembers things like Trumpet WinSock and so on, you'll remember. It certainly was not the ubiquitous technology that we expect today. And indeed, if you remember back far enough, Bill Gates wrote The Road Ahead. He barely mentioned the internet. It was all to do with very centralized network services, and Microsoft had a project called Blackbird, which was supposed to be a proprietary data solution for the Microsoft network. And this was even in 94, 95. And then, as we know, things changed. So what's the synthesis that came out of this? Computing will be an increasingly ill-defined admixture of local and central control. For example, the cloud. Now, I say ill-defined, it's not because nobody's bothered to define it yet. It's because its ill definition is somehow part of the sales opportunity and the technological opportunity. Sometimes this is benign, but sometimes it isn't, as we'll discuss. So if we're talking about the cloud then, and we see it as almost a postmodern version of the PDP-11 scenario, then the question is, what differentiates the cloud from network services we have had since before the ARPANET? And there are plenty of good technical answers to this, but perhaps there's a skeptical answer as well, and that might be termed intentionally obfuscating abstraction. In other words, there is something inherent about the cloud model which makes you recoil from asking too many questions about it. It's not your place to ask questions about it, because that's the point of the cloud. Now, we need to be a little bit more pretentious. Hegel wasn't enough. So what we're going to do is we're going to move to have a discussion of Jacques Derrida, who was a semiologist, who made a mistake early in his career. Almost everything he wrote was almost completely incomprehensible. Early in his career, he made a mistake by writing something that was nearly comprehensible, and it was called Plato's Pharmacy. And this actually isn't something that I've just kind of leveraged to be pretentious into the talk, but I had a problem with the cloud, and I suddenly remembered back to my studies of English philosophy and said, this is ringing a bell, and you'll see what the bell is. So in this essay, Derrida discusses Plato's Phaedrus, and within Plato's Phaedrus, we have Socrates retelling an ancient Egyptian myth about the origin of writing in human society. In other words, how did writing begin? We had lots of oral cultures, and then suddenly writing started. And of course, there is already 3 levels of alienation. First, you have Derrida discussing a story in Plato, which is discussing Socrates, which is discussing an old Egyptian myth. So we're already getting a very interesting notion of what writing does to an oral culture just there. In this story, an Egyptian god gave writing to the king, but the king wondered whether to reject it or not because he realized there would be some problems. And writing was termed a pharmakon to memory. Now, that's what it was in the Greek. So what do we mean by pharmakon? Now, English and German indeed have the term, pharmacy, pharmaceutical, and so on. So we can almost understand it. Now, in Greek, pharmakon means a medicine. It means an antidote. Annoyingly, it also means poison. So you have one word which effectively means its opposite. And this is a peculiar situation. But it's not that peculiar because, as we know, many poisons in certain doses are medicines, and many medicines in overdoses are poisons. So it's not as odd as it initially seems. But for years, people argued about how best to translate this word. How do we translate it? Did he mean poison? Did he mean medicine? Did he mean that it poisoned memory, or did he mean that it was a salve to memory? And Derrida argued that there is no correct translation. More generally, he suggested that conflicting meanings are at the essence of our linguistic experience and never collapse into an eigenstate, to use the scientific term. There isn't one meaning that we can then discuss. And we can see how this works. And this was discussed by Derrida and by Socrates himself. On the one hand, writing preserves memory. We only know about Socrates because of preserved writing, for example. Without writing, a lot of culture gets distorted or lost. On the other hand, writing can atrophy memory. It can destroy memory. Writing is, after all, an abstraction. And once it's written down, the living word that was part of that memory is no longer accessible. It can destroy the vitality of an oral culture. It can make us sterile and logocentric. Writing poisons and ossifies speech because writing, after all, are just symbols on the page, and we're constantly having to reinterpret them, and without the knowledge that there is an oral culture which has helped us to transmit these ideas in a more fluid way, we can be very, very lost when trying to interpret any bit of writing. So we can see how it's used in both ways. Writing can destroy the vitality of oral culture. It can make us sterile and logocentric. Writing poisons and ossifies speech. Thus, the ambiguity of the word pharmakon is not a problem to be solved. It's not a puzzle where we can turn over the page and find the correct answer, but it is inherent. The very reason that word was chosen is because it shows us the problem with the metaphor and with the concept. Derrida argues that language was full of pharmakons, that words could never have a fixed meaning. Words do not collapse, as I said, into eigenstates. They're always constantly in play, always in superposition. Words are always ambiguous, semantic clouds, always contradicting and confounding. The moment we are presented with a thesis, the antithesis automatically suggests itself. Freedom, for example, is a word we all know very well in this audience, but it invokes the strictures required to protect it. Anybody who wonders about this just needs to think about the arguments concerning the GPL, where people argue that the GPL isn't as free as the BSD because it tries to defend its own freedom. Life makes no sense without death, and so forth. We always, therefore, need to be suspicious about buzzwords that do not acknowledge their ambiguity because they try to use their very obfuscation to anesthetize us from considering their problems. And I suddenly realized one day that the cloud is one of these pharmakons. It is a kind of self-defeating, self-questioning metaphor, and that's why I felt uncertain about it. The cloud, as we know, promises efficiency, liberation, agility, transparency, value. And a decent argument can be made for each of these descriptions. Using resources in the way that the cloud allows is more efficient. It can liberate you from the tyranny of having to get specific contracts for specific bits of metal. Agility, we can spin things up, spin things down. We can have our data distributed wherever we need it to be, whenever we need it. It can be considered transparent. It can be certainly considered good value. You just use what you need. But on the other hand, the cloud also can suggest inefficiency, subjugation, rigidity, opacity, and costliness. And we can all think of examples where this is true as well. There are certain things which simply do not work properly in the cloud infrastructure. if we're trusting all our data and all our hosting and all those kinds of very important information resources to very ambiguous organizations where our relationship is not properly understood and where the technology that's providing these services is not properly described, then in a sense we are subjugated to somebody else's business model. And there is a certain rigidity. And there's a paradox to this rigidity because we're constantly told how, for example, cloud hosting is very efficient and very useful, but then we're constantly logging into the Ubuntu planet and finding out the myriad different ways you have to coax various cloud services to work properly when you spin them up and spin them down to do things right. So it's not that you're being liberated, you're just being moved into a new problem space, which may or may not be useful for you. And costliness, it's all very well saying you only pay for what you need, but then this doesn't take into account volumes of scale and amortization, as people who, say, come under DDoS attack when they're using per minute or per byte billing find very quickly. How did the metaphor begin? Well, I look back, and actually, I think we know how the metaphor began. We've all seen those sort of diagrams. There's one from 1998. What did the cloud mean in that diagram? It meant that bit of the network where you said, yeah, whatever, I don't care or know about that bit. It's not my problem. So you had your LAN, you had your network infrastructure, and you said, and then it all goes over there, wherever there is, and then it sort of comes back somehow, but that's not our issue. And I think it's telling that that was the beginning of the metaphor. I don't care or know about that bit. Thus, we have a semantic problem. Let's imagine a cloud about which you know everything. So you know every transistor that's used to provide its service, you know every layer of the platform, you know its exquisite capacity and its exceptional limitations. And imagine a cloud about whose particulars you care entirely. You don't just want to say, I don't care about that bit, it's your problem. You're running, say, a PCI compliant or ISO 27001 service, and you need to know everything about who's used that particular system last, when it expands, what are the memory protections, and so on. So if you care completely and you know everything, is it still a cloud? I don't know. It becomes an interesting semantic problem about when a cloud stops being a cloud and just starts being an agilely provided cluster of services. And even if it is a cloud, is it still the cloud? I don't know, any more than my uncle does. But you'll have people who nevertheless will be arguing that you must use the cloud or you mustn't use the cloud, and yet they're not necessarily defining what they mean by it, and therefore we are left with these very ambiguous questions, which on the one hand might seem trivial semantic puzzles, but on the other hand have very significant real-world problems, as we'll discuss. And I'll give you an example. I'll give you an example from a project that we worked on as a company directly. Now, we have our own open-source data center in Cambridgeshire, where we host a lot of things, but we also provide managed services on all sorts of platforms. And we were running helping to run with our partners a very big play-along game show to a television program. And you could log on to an app in your web browser or your phone, and you could play along with the television game. It was called the £1 Million Drop and then the Bank Drop. And the database, the data services for this were running in our data center on Metal, but the actual game servers were run across Amazon Web Services, and we distributed those across however many number of instances that we needed. And we were obviously working with our partners who developed the application and with the television company who was broadcasting the show. So we tested it, of course. We tested spinning up instances, spinning them down again. And we used an Amazon Web Services virtual load balancer to make sure that all the services were balanced as they needed to be across these number of instances. And of course, when you've got a broadcast program, you need to do this because you suddenly have broadcast levels of concurrency for an hour or two, and then it comes right down. So everything worked well in the tests, But then on the first night, we found that the Amazon Web Services load balancers weren't doing two very important things. They weren't balancing the load, which is kind of what you want a load balancer to do. They were sending all the traffic to one instance. So the contract was with our development partners who spoke to Amazon, and Amazon said, we're not going to tell you why this is happening until you buy a silver support contract. So they bought a silver support contract, and they said, now can you tell us why this is happening? The TV station's shouting. So the reason it's happening is that you did not ask us to warm up the virtual load balancer. I said, what? Is it running on thermionic valves? So we said, can you tell us what you mean by warming up the load balancer, please? They said, no, we're not going to tell you. That's an internal secret. And we kind of guessed what it meant, as I think some people do. But I said, in future, just drop us an email an hour or so before broadcast. We'll warm them up for you. And can you tell us anything more? Is there anything else? How warm will it get? You know, if we go above 200 instances, do we need to tell you to turn up the temperature? There wasn't a reply to that email. And so we just ritualistically, 2 hours before broadcast, sent an email to Amazon Web Services and says, hello, we're about to be broadcasting. Can you please warm up the load balancers? And then something happened, and then it worked. Now, for something that's a throwaway service, you know, it's a game show. All the data was in our data center. We knew what to do about it. That's fine. But you're beginning to see why the notion of the cloud as an ambiguous pharmacon metaphor comes into play in the real world when you have issues like that. Now, it's no surprise that none of our PCI Level 1 compliant customers want anything to do with that. Now, that's not to say they don't want to use agile technologies. We have a couple of clients at the moment who are spinning up in our data center their own private virtualized clouds and networks and all that kind of thing. But the point is, as I described earlier, they know exactly what every component is doing, and they literally have auditors crawling around our server room, making sure that there's chicken wire put under the floor so that people can't crawl in. It's to that level of detail. So it's not the, well, email us a magic incantation to warm something up. Now, we know how to use LVS load balancers. We know how to use appliance load balancers. We know how to configure them so that they balance load up to a certain number. And we know the problems that can be caused by certain of these technologies, and we know how to fix them at 3 in the morning, even if it annoys us. This is an example of a problem that can't be fixed with any of our skills, and that worries us. It worries us in the same way that we were worried in 97 and 98 when people started wanting to host with Windows platforms, because with Linux, we could always go back, read the source code, find out what the issue was, and fix it as we needed to. And again, this was not a theoretical problem. Anybody who's ever done hosting with Apache in a shared environment and wants people to be able to run their scripts as their own user knows that there is a wrapper called su-exec, which allows individual users to run their programs and puts them through a number of security checks first. And it wasn't working well for us because we had a different directory hierarchy than su-exec demanded. So we simply read the source code, commented out one of the security checks because we realized it didn't apply to us, recompiled, bang, it worked fine. We were able to do things. If we were in the more clouded environment of proprietary software, we would have had a problem. And we didn't like the feeling of that. Similarly, we didn't like the feeling of disempowerment that came with this anecdote. And there have been several others since. Weirdnesses where we were told that an elastic database service would expand as required, and it did expand, but it suddenly reached a ceiling and wouldn't go any further. And nobody would tell us why it wouldn't go any further. If you're running a MySQL cluster or a Postgres cluster on a bunch of RAIDed drives, you run iostat, you have a look at top, you check the caches, and you know what's going on. With this, somebody else's agenda was occluding our clear view. And by the way, that last slide was a pharmacon conundrum to me as well anyway. Now, the cloud also has another big problem, which you will realize very clearly, but which we need to make distinct. And that is, it's one word that has two completely different conceptions if you're a user or a dev. Now, even if we concede that these conceptions are vague and self-contradictory, they are two different universes of self-contradiction and vagueness. For users, cloud means a magic syncing and storage god. So iCloud, Dropbox, all these services that allow you to put your pictures and your tunes and your documents and your contacts, and you throw them up in the air and hope they stay there until you want them. And you don't really care where they are, what they're doing, or who has access to them. For devs, the cloud is an elastic commodity serving slave. So you see, they're actually two quite distinct things. The thing that unifies them is the notion that we're not allowed to care about the fine details about what goes on to give us that magic. That's the key unifier here. So anybody here know when you synchronize your contacts to iCloud on an Apple iPhone, what server is it on in which data center? How is it encrypted? Who has access to it? What guarantees have been given about that access? Don't care. When you're an elastic commodity serving slave, you spin up an image somewhere. Who else is on the same metal as you? What are the true partitions and security issues with regard to keeping the VM separate? Who has access to the full view of all these systems? Is there a master login by a government or another? I don't know. Don't care. Because we just get per minute billing and it works. So neither of these expectations is unreasonable. You know, it's nice to have things synchronized to the cloud. It's nice to be able to spin up a VM. It's nice to be able to then increase the resources available to that VM as you need to. And it's something we use all the time. But both of these can be misguided if they are treated as utopian. If we don't ask these questions and we just drink these technologies as if they were mother's milk, then we have an issue. And we've seen all these privacy headlines for users and dev. I've just literally pasted various headlines and quotes that I found in the last couple of months. Evernote hack makes private notes public. FBI pursuing real-time Gmail spying powers as top priority for 2013. They may have other priorities now, but that was their top priority a week ago. Yahoo Mail convicts Chinese dissidents. We remember that one. 1 in 6 Amazon S3 storage buckets are ripe for data plundering. Now, does this mean that traditional technology solutions don't have problems? Of course not. We all know of that old box in the corner that was rooted. We all know about that strange old Cisco appliance that was hacked 3 years ago, and everybody's been sniffing our traffic ever since. The thing about those, though, is that that's our fault, and it's under our control. It's our fault for not having patched it. It's our fault for not having run sufficient intrusion detection. And when it comes down to it, we can, if we wish, flick the switch on that machine and build another one afresh. These issues are not necessarily our fault, except in as much as we rely on them to the degree that we don't take proper cognizance of the problems that might occur. Another issue, of course, is clouds evaporate. We all know that Google closed down their reader service recently, and various other services just disappear like that. And it doesn't even seem to make much sense to even sign up to a commercial variation of these services. We have a group of customers who are using a version of Google's search services that were specifically paid for and targeted for their own websites that they could then tailor and run and have some running locally and some with Google, and they just closed that down, and there's no alternative to it. So of course we're building that alternative out of open technologies. And as another quote said, cloud services disappear with data. That's more problematic. Where the cloud server disappears, there's no easy way to get your data out, and it's gone. And this can be a very important issue, or it can be a trivial issue. I'll give you an example of a trivial issue which nevertheless is important in its scope. My sister-in-law had uploaded all her photos to Facebook, which is what a lot of people do these days. She then had deleted them all from her local camera and her local computer because they were just wasting space, and anyway, Facebook would look after them. She was then mistakenly misidentified as a spammer on Facebook because somebody else had a similar username, and so her account was closed down, and she lost access to all her photographs, and she tried to find out what was going on, sort of emailed Facebook, there was no response, and so on. And so eventually, after a lot of battling, she was reinstated, but for 2 or 3 weeks it looked like all her photographs had been lost. Now, of course, that's her fault for not keeping the backups, but on the other hand, she believed the hype because the hype had been promoted to that degree. It's all fine, it's all going to be looked after. It's in a heavenly realm, though. It's in the clouds. It wasn't quite like that. And these problems go beyond utilitarian. No, they're not just, how many bits and bytes are we going to save? You know, there are the slightly amusing aspects of it as well. SimCity release an always-on debacle. I've got a friend called John Walker who writes for Rock, Paper, Shotgun, and he detailed this precisely. Even our games now are being installed on the cloud without necessarily needing to be there. So if you want to play your game on the train, you can't because it needs an always-on perfect connection. And the funny thing about SimCity is that that connection had been promised as offering additional value because computing would be done on the cloud. They never specified what this was. And then they found out it wasn't anything. It was just there as a kind of security measure to make sure that you were the legitimate owner of the game. And we also, in the headlines, many Wii online services are shutting down, and they're gone, and that's it. So it just works, I don't care how, is magical, and it's useful, and it's tempting, until it doesn't work. And then you do care, and you start caring a lot, and you realize there are limits to how much you're allowed to care. And this leads us to a model of computing which I've called fast food computing. You know, we want it delivered quickly, we want it delivered now, we don't really care what the ingredients are, we just want to make sure that they're cheap and as tasty as they need to be to fill the hole in our lives at that minute. And fast food computing is fine, but then you start finding the equivalent of horse anesthetic inside your computing meat, so to speak. And I'm sure there have been scandals in this country, as there have been in the United Kingdom, about this sort of thing. And there is danger that computing can be going in the same way, in that we're having a race to the bottom for costs. We're having an obfuscation of the supply chain so that little offcuts of computing, like little scraps of meat, are all being thrown together and sold as one piece of computing, and you don't really care where that computing's come from as long as it does the bits and bytes you need to. For many projects, that doesn't matter. For some, it has huge implications with regard to stability and, more importantly, civil liberties. And are we moving forward or backwards in our models? Let's look at the model of Usenet and home pages versus Twitter and Facebook. In a sense, we got the same social performance out of both of them, if anybody remembers what Usenet news groups used to be before they were just pornography and piracy. Usenet was a decentralized, open, scalable, non-proprietary platform with APIs and clients completely decoupled. So you could have your social media, you could have your discussions, and you weren't limited to an arbitrary number of characters either. And you could choose which Usenet service you used, and you could choose which client you used, and you could choose which groups were taken. And censorship was extremely difficult because it had to be percolated across the whole Usenet system. Twitter and Facebook, compared with Usenet on your own home pages, is a centralized, closed, restricted, proprietary platform with APIs and clients tightly regulated. So it's interesting that we've actually moved from something that much more gives the promise of what the cloud is supposed to be to something which seems to be a lot closer to that 1960s centralized model, and yet this is the model that's being called the cloud. Anybody who's tried to use an independent Twitter client recently knows that this has real-world implications. Twitter basically want to kill all independent Twitter clients so that they can make sure that the promoted Twitter adverts appear in their own official Twitter clients and can't be stripped anywhere else. So we have an issue that is interesting, because if I'd have said to you 10, 15 years ago, the Usenet Corporation says that you're only allowed to use X News and no other news client, you would have looked at me as if I were mad. Now I say the Twitter Corporation says you're only allowed to use their official Twitter client. I say, oh yeah. And it's interesting that we've accepted that change as a kind of mark of progress and a mark of moving into a more cloud-based, brave new world. Yeah, both of those technologies, the old and the new, can be considered cloudy, but the modern variants seem to represent an enclosure of the commons. Here, the notion of the cloud is being used to obscure the privatization of our network opportunities. And the enclosure of the commons is interesting. I'm not sure whether Germany had an equivalent of what happened during the agricultural revolution and before in the United Kingdom, but there used to be common land on which anybody could graze their animals. And then that common land was cut up into little strips and then effectively given to small landholders, and people were turned into serfs. And one gets the feeling that something not too dissimilar is happening here. Some people will say, that doesn't matter. As long as we get the services we need, we don't need to worry about where it is, what it is, how it's being provided. Okay, so Twitter only provides their official client. Okay, so Amazon Web Services won't tell you what the load balancer is doing when it's warming up. But actually, computing these days is fungible. In other words, computing is no more than a bit of ore or a bale of wheat. One bale is pretty much like another bale. One bit of ore is pretty much like another bit of ore. Just go for the cheapest, most efficiently produced version of both. But there are constantly these little real-world effects which break down the concept of fungibility. And I'll give you another small example. We wrote again with Amazon Web Services and with another game show that we were supporting, we wrote an OpenID platform which allowed people to log in. And then it would email the user for confirmation, and they would email back, and their password would be confirmed. We all know how that works. And again, it worked perfectly well in testing, worked well in the first broadcast and the second broadcast. Third broadcast, none of the correspondents were getting their email back. And we said, why is the email not going out? We looked, the SMTP server was sending it from the Amazon Web Services instance. It was being recorded as being delivered. And it was very puzzling because it appeared to be delivered, and we noticed that suddenly it was being detected as spam by AOL and I think Yahoo. I said, why is it suddenly being detected as spam? There were no particular spam words, it was requested. We did quite a bit more investigation and found out that the elastic IP address, which had been given by Amazon to this particular instance that night, had been used an hour before by a Bulgarian group of spammers to send out tons of spam. We took that IP address, and guess what? Now, you wouldn't guess that sort of effect before it happened, and then you suddenly say, well, it's obvious. And we're beginning to see more and more of these effects that when you're just running around in an apartment block rather than in your own house, these sorts of things tend to happen. And this principle of open simplicity, as you well know, goes beyond the cloud. We support both, for example, Linux kernel RAID and the proprietary RAID systems that come on the motherboard and on very expensive cards. At 3 in the morning, I can tell you which one I want to fix. Linux kernel RAID will go wrong, and it'll go wrong in very annoying, stupid ways, and it'll be slower, and there'll be some kernel bug which does all sorts of annoying things. However, I know that by 4 in the morning, I'll have some sort of fix. Proprietary RAID system, that's suddenly written rubbish all over the primary partition. I log on to the weird boot screen, and it says copyright whenever Taiwan, and I think, what do I do now? What has it done? And there is no further way of solving that particular issue other than hoping, perhaps, that they've introduced some sort of patch to the firmware. Or you search Google and see if there's some magic solution. Again, we are not empowered to solve the problems of our clients with these sorts of issues, and that's an obfuscation. It's to do with the proprietariness and the obfuscation. That's also the problem with the cloud when you expand that into general computing. So what are the implications for an open data center, since this is the open data center, of moving to a completely cloud-based infrastructure? All your clients now want cloud-based infrastructure. Your data center has to be ready for it. What do we do? And this is more of the sort of utilitarian problems. Well, we know there's an expensive upfront investment. The cost of setting up NASs and shared storage, even with brilliant projects like Ceph, is not cheap. And there's no guarantee of return, because the whole point of a cloud from a service provider's point of view is that you have to keep it as packed with people using it as possible to pay for it. So it's a bit like we are suddenly going into the cheap airline model, where you have to oversell every seat to make sure that you have as many people sitting on that plane when it takes off. And we're suddenly having to worry about that. So there's no guarantee of return. And of course, there are smaller margins, but that's fine. That's just capitalism in the way it should work. The problem is there is a consolidation of power with the bigger players. We have Microsoft giving their cloud, and we have Amazon giving their cloud, and now suddenly, is that going to be what hosting is? Because if it is, that's a problem, because we get to a much bigger concern than even, remember when Yahoo took over GeoCities? Remember GeoCities? Everybody hosted their funny flashing web pages on that in the 90s, and then it got closed down. And one day Yahoo decided to close it down, and it was closed down. And so many hobbyists and other people had concentrated their hosting on GeoCities, and one company decided to change the way it did things, and millions of people were affected. Similarly, if hosting is concentrated in 2 or 3 very powerful conglomerates, what is that going to do for innovation and choice? But more importantly, what's that going to do for information security and freedom of expression? We already know what FBI's top priority was. If FBI have to talk to 1,000 small hosting companies, or just goes and plays golf with the CEO of one big hosting company, which one's it going to prefer? This isn't conspiracy theory, this is just policy. And of course, there is less transparency of service to your clients. There has to be, because you have to you're effectively, literally pretending they're getting something they're not. It looks like it's a real computer, and they know that it's not, but it's still, they can't really know that one of their images was spun up on that junky old machine in the corner, and another one was spun up on that nice rack over there. It's not for them to know. And not necessarily even the power savings that are promised can happen, because you have to install such a high density of services to begin with that you have these issues. And if we look at the moment, Intel and various others are introducing open compute architectures to try and strip away all the things that hosting environments don't need. But that's not cheap. And it's not going to be cheap for the smaller providers either. And the analogy I can think of is, it's happened in this country, it's happened all over the world, where cinemas were bullied to move from traditional 35mm projection to digital projection overnight. And the reason that that was needed was nothing to do with providing better service. It was cheaper for the studios to distribute the information, and also they had what they considered rock-solid DRM on it. So the bait and switch campaign for that was 3D. The reason suddenly everybody went crazy about 3D is that they wanted to force cinemas to do it more quickly, so the studios started producing a lot of 3D material, promising that this would be the future. Cinemas had to then pay for the investment to convert, and a lot of small cinemas couldn't, frankly, afford to do it and shut down. Certainly in England that happened. So there is a comparison here with computing as we move into the cloud environment. Now again, right to my second slide, I am not dissing OpenStack, Chef, Ceph, and all those other agile technology organizations. They're producing projects that we as a company use every day. It's just that we need to be careful about separating those agile, useful technologies from the political and socio-economic forces that can sometimes distort their use. And we know that there are degrees of danger in sacrificing freedom for convenience. How many of you go around these days and find that your favorite sites now are increasingly pushing you to use Facebook as the login? So I don't want to use Facebook as my login. But you notice that the Facebook login with Facebook button is getting smaller, and the login with our own login services is getting smaller, and the Facebook login is getting bigger. Things like YouTube, where they are removing things because of fake digital millennium copyright notices. There was a wonderful project in Germany, actually, called the Open Goldberg Variations Project, where Kickstarter funded a free and completely open version of the Goldberg variations. Somebody uploaded it to YouTube. It was in the public domain. YouTube then pulled it down because somebody else had identified that the Goldberg variations were being played, and they'd misidentified it as by another orchestra. We hear these stories every day. Stories about Dropbox and their hashing mechanism, which a couple of months ago we heard about from a colleague, had mistakenly put somebody's document in somebody else's box because the hashing mechanism had gone wrong and there'd been a duplicate. Whoops. My father, who is actually a judge in Britain, wanted to use Dropbox to synchronize all his cases in. I said, no, you're not going to do that, sorry. And he got annoyed because all his colleagues are doing it. I said, the last thing you want is that somebody, before you've promulgated your case, reads about it 2 days before in the newspaper. So let's use another solution. And I taught him how to synchronize things securely. So if we are going to use cloud-based technologies, what are the questions that we need to ask ourselves? And one of those questions, here are the questions that I advise people. Are the systems at least using free software? Are they based on free software? Are they using something like OpenStack? And on top of OpenStack, are we using a nice Debian stack, or are we using Ubuntu or SUSE or something? Or is there something else going on? Is there some magic sauce that's going to try and keep you caught there? And can I replicate those systems? In other words, I've got system A and system B set up in the cloud. If I wanted to set it up in a completely different architecture, would it be easy to replicate? Or is there something there to do with licensing or technology which has locked me in? Now, is my data easy to back up? Is there so, for example, and this is a big problem, often when you use these technologies, they will charge you for bytes in and bytes out, which means that doing a good rsync backup or something like that is difficult because you're paying every night through the nose to do it. So you need to make sure that there are ways around that that work for you. Because if you don't, it's very easy just to say, well, why would I need to back it up? It's in the cloud. Is my data easy to export? Of course, is a very different sort of question to back up. And that is, oh, I'm using this new big data system that just takes all my data and stores it in some weird hashing table, and it's fine. Say, yeah, but what if I need to take my data out again? Is it still fine? Will it work? Have you tested the export mechanism when that moves to 5, 6, 7, 10, 20 million rows? And how known is the infrastructure? Do you understand at least 90% of the way the infrastructure you're using works? And then you need to decide, is that 10% of ambiguity okay? Does it matter that you're being asked to warm up various bits of that infrastructure an hour before you need to use it? Or is that a price you're willing to pay? And those are questions you genuinely need to ask yourself. And we revisit the Unix philosophy, and I won't go over it, but these are the sorts of questions and principles behind the Unix philosophy. And I think a lot of them are relevant in the cloud-based world as well. If you're going to use these small, dumb, cloud-based instances, these are the sorts of things that I think we need to still keep in mind. These are from the Unix philosophy guidelines in the 80s, and I think many of them are still very useful today. Choose portability over efficiency is one that I noticed. There seems to be an increasing use of binary databases for speed and so on that aren't properly cached back to text-based systems, which makes getting that data back out difficult. So we're coming to the end, and we need to ask ourselves with each network project, how much do I know about the technology I'm using, and how free am I? Liberty isn't some optional seasoning. It's not something that's nice but you can get away with. Your project may fail one day without liberty, but it will fail one day without it. I mean, it may but it will without it, because at some stage, you're going to collide with somebody else's business model and somebody else's agenda or somebody else's change in circumstances, and you will find that you do not have the right to change course. Now, it might not happen within weeks or months. It might happen within years. And that's even worse because you will have forgotten that it was a problem in the first place. It's not like that old COBOL box sitting in the corner since 1958, which you only need to deal with in the year 2000. Because it's not your little COBOL box sitting in your corner. It's somebody else's collection of who knows how many boxes sitting in their corner. And that's something that you need to make provision for. So I'm not saying don't use their boxes, but make sure that you have your own box ready to take over if need be. So at its best, cloud hosting is like the fractional banking system, and we know where that got us. Effectively, resources are being printed, and we're using them, and we're effectively being loaned these resources and over-provisioned these resources, which initially makes the computing economy more efficient, if you like. So, okay, there's an overcommitment of resources, but we're hoping that they won't be the equivalent of a run on the computing bank. Because actually, a cloud provider works by promising you a lot more in power and resources than they actually have, hoping that your VM will be able to spike when other people's VMs aren't spiking. And they make that calculation like the banks make the calculation, which is why, at its worst, cloud hosting is like the fractional banking system. And similarly, with the fractional banking system, it can create a very useful, efficient, and creative computing economy, or it can come close to destroying it all and need some sort of bailout, which will happen, we'll see over the next 10 years. So finally, as open data center providers, how can we give our clients the benefits of the cloud without the overhyped ambiguities? We need to be transparent about our services basis. We need to say, actually, while we're committing you X, in reality, we can only give you Y, and X is a best case scenario. Build upon our open source and free software heritage. Constantly look for projects that will leverage that open source and free software, and don't be scared about sharing that knowledge with the client so that every aspect of the stack becomes transparent. And do not provide abstraction just to be cool. And this can sometimes be a temptation. We provide all sorts of VM services and private cloud-based services and so on, but 9 times out of 10, we still run databases on the bare metal. Why? Because databases seem to like having the bare metal as close as they can. They have access to the full array of SSDs. They have access to the full memory. And they seem to work best. Benchmarking doesn't tell lies. That's the case. So we give them the old-fashioned cluster of boxes for their database services. It's less cool, but it works. Cloud or metal, does it pass the 3 a.m. test? You're sitting there at 3 in the morning. You've just been woken up by an escalation page. You go to your online documentation. Your eyes are blurry, and you say, how am I going to solve this one? The one that passes that test is probably the one that's worth considering. And remember, at the end of the day, it's all electrons and photons on hot metal and silicon. Let's not pretend that this is some sort of heavenly solution to our problems. So, coming to conclusion, is obsessing about freedom and openness in complex systems really that important? Aren't we being just a little utopian? Well, I'll give you a real-world example of people who put their trust in a cloud services provider. It was a platform as a services provider. Let's see an example of this. And I'm taking direct quotes from that service provider's website here, which you can find in the Wayback Machine. They said they were a non-transparent platform as a service provider, and they said, our sophisticated proprietary automation and unparalleled client service delivers an enhanced execution that is virtually unmatched in our industry. So again, using proprietary claims to say how special their service was. We didn't need any transparency or freedom because we could trust their high, prudent risk management policies. They were to be trusted because they were to be trusted. A tautology there, but never mind. It makes good prose. And their proprietary solution was necessary because it minimized errors and maximized efficient processing and rapid communications. We've heard this argument for proprietary systems often. Okay, the open system is nice, but it's inefficient. There are errors. We're bulletproof. But it was okay, they had one of the most sophisticated disaster recovery facilities in the world. But as you'll find out, it depends how they define disaster. The owner's name is on the door, they said, so you can trust them. He has a personal interest in maintaining the unblemished record of value, fair dealing, and ethical standards that have always been the firm's hallmark. So which firm is this? Remember, this is direct quotes from their website from a few years ago. It's not there anymore, as you'll find out now, because the owner's name was Bernard Madoff. And remember what his service provision led to when people trusted effectively what was a financial cloud service. Now, We could say that he did have a personal interest in maintaining the unblemished record value, fair dealings, and so forth. And we can say that he certainly minimized errors and maximized efficient processing. But people were missing the wood for the trees by not asking fundamental questions about whether the system was trustworthy at a much deeper philosophical level, which is why it's important sometimes to stop and step back from the XML schema and the databases and the presentations and just to wonder what are the real world and philosophical implications. Valuing openness and transparency is not sentimentality. It's not that we're all hippies. It's self-interested skepticism. It's for our own self-survival that we worry about things. And the cloud, as a pharmacon, is a self-defining warning if you don't worry about such things. Now, some of the tech ideas associated with the cloud are valuable and logical extensions of client-server computing. I'm not here to throw the baby out with the bathwater. But some of the hype is just there to be cloudy. Now, finally, if someone proposes the cloud as a technical solution, as a Gedanken experiment, ask them to put the proposal to you again, but without using the word cloud once. So say, tell me everything you want from this technical solution, tell me the values you want and the final way you want the project to work, but never mention the word cloud or any other hype metaphor. And then we'll see how best to give it to you. And we'll end, we've had so many philosophers today, let's end with Wittgenstein. And we all know his famous quote at the end of Traktatus, where he was discussing the limitations of philosophy. And he says, wovon man nicht sprechen kann, darüber muss man schweigen. And I thought maybe we'll have Wittgenstein 2.0. Wovon man nicht sprechen kann, ohne the cloud zu erwähnen, darüber muss man schweigen. So that's it. I don't know if we've got much time for...
Oh, we have 5 minutes for questions.
5 minutes. I mean, I suppose there aren't actually questions, so if anybody just wants to discuss stuff, that would be good. Yeah.
You might add Google Plus as another candidate.
Sorry.
Great talk.
Thank you.
You might add Google Plus as a candidate for not really open APIs.
That's a very interesting case, because the whole point of Google Plus originally was, well, they tried to make it seem as if it would understand and learn from Facebook's mistakes. But Google Plus isn't Usenet for the new world reimagined on modern broadband computers. It's just another proprietary network, isn't it, really? And people have exactly the same problems that they have with other proprietary networks. It doesn't matter how shiny it is if you can't open the bonnet and look at the engine. And that's effectively what we're being told to do with all these technologies. Google Plus has its own problems in that too few people are using it. But yes, it didn't offer the response that people hoped. Google have tried to do other projects where it looked like they were at least tentatively responding to things. Remember Google Wave and Google Buzz and all those sorts of things. Google Wave in particular. But the problem is they overcomplicated it, and it didn't work as nicely as it was supposed to have. But yes, you're right.
One more comment on this entire situation. What I've learned a long time ago, not necessarily related to clouds, but in a similar context, is if you want to try to make management understand that this cloud stuff is possibly not the best idea, what I found quite helpful is to ask for penalty agreements. So, first thing is you ask for white papers to actually get some technical data, and you frequently don't get that, like you said. And then you ask for a penalty agreement and how much they will charge you for that extra. And frequently you get told, we don't do that, which means well, we're doing crap in our data centers. Or they come up with a ridiculous price, and then you just need somebody who knows a bit about insurance mathematics to figure out what they're anyway, but you can leave that to management, to the MBA people. That's sometimes quite helpful as well.
That's true, and the general point you make there is true too, in that the principles of skepticism don't require that we understand what all the acronyms mean and understand what the buzzwords mean. You just have to use your general skeptical business brain and say, well, actually, you're promising X. How do we hold you to that promise? How are you going to be transparent? Now, what we do is whenever we are about to sign a big contract, we basically demand that people come to our data center and we give them a tour, and we take them to the data center on the day that we're doing the power testing, and they see us pull the lever, they see the generator turn on, and they know that what we've said we're offering works. Because that's very important. And we say, if anybody's going to provide you a solution that goes right down to the basics of understanding how it works, they need to offer you something equivalent. You need to see that the door to the data floor isn't being held open by a fire extinguisher, which I saw in a data center a few months ago. You need to make sure that the air conditioning is actually working at the temperature they say it's working, and that the racks are individually lockable. There are plenty of organizations that will not show you anywhere around their facility. And there's one famous one, it's a competitor of ours, so I won't mention their name because it's unprofessional, but they have a lot of data centers across the world, and they won't allow people to see them. And the reason they won't, as I know because somebody visited there, is that some of them just have tower machines piled up from the floor to the ceiling, effectively. And nobody wants to go in a data center and see that. So yeah, it's clear why some people don't want to hold up those promises to scrutiny.
It's not a question, Nicholas, but rather a comment. So you picked up many negative points about the cloud computing, but to be honest,